Good morning. So today is going to be your first pre-recorded lesson. So I'm going to go through some of what I consider the most helpful things to remember from Math 3. So I do encourage you to actually get out your notebook and your pencil and follow along with me and take notes just like you would in class. Now, if I'm going too fast, which I might because there's nobody in class raising their hands to say stop, remember you can pause this video or you could rewind this video and you could do it over and over, which is kind of the benefit of having it pre-recorded. So go ahead, get out your notebook. I'll give you a second. You can pause this video. And then follow along with the lessons. Now, at the end of the lesson, there is an assignment in the modules. So make sure to take good notes, follow along, try to really grasp this understanding, and then move over to the modules for today's classwork assignment. All right, today's lesson, key things to remember from Math 3. So the very first thing that we are going to work on is just factoring. You guys have been factoring since Math 1, but it's a skill that just does not go away. So we're going to work out these two problems. This is a trinomial because there are 3 terms in it. And this first one is probably the easiest problem we'll do all day. All right, this is where we open up the 2 sets of parentheses. Now, the only way that this could start with an x squared is if each term was x and x. Now, this is where we have to do some brainstorming that kids hate. Can you come up with 2 numbers that when you add them get 7, and when you multiply, they give you 12? So, pause the video, see if you can remember the 2 numbers that add to 7. And that answer is positive 3 and positive 4. And actually right there, since it only asked us to factor, we are done with that problem. Now, the second problem is going to be a little more challenging, and it's challenging because there's a leading coefficient. So a leading coefficient, teachers have come up with a ton of different methods. So if I don't do this the same way you remember, that's okay. You might have done grouping, you might have done box method. I do something called a slip and slide, but there are just many right ways. So I'm going to show you how I do it. What I do is I take that leading coefficient and I multiply it by the last number. So it becomes basically a new problem. X squared minus 7x, and now that's a 30. And what I'll do is I'll factor that because without a leading coefficient, it's much easier. So what multiplies to negative 7 and adds to negative 30, be real careful here because these have the negatives in it, so keep that in mind. So obviously that answer is negative 10 and positive 3. Now, remember, we're not done like we were in the last problem because we moved that leading coefficient. We can't just forget about it. So the way we account for it is we take that last term and divide by the leading coefficient. And then we're going to reduce that fraction if you can. So 10 over 6, I actually messed up. Hold on, that's a 3. 10 over 6 is 5 over 3, and 3 over 6 is 1/2. Okay, we've got one more step. So whatever number ends up being in the bottom of the denominator, you're going to slip and put it back out front. So this is end up going to be a 3x minus 5 and a 2x plus 1. Now, here we are finally factored. You could always kind of check to see if you got it right by FOILing. So for example, if I multiplied 3x and 2x, does that give me 6x squared? It does. So that is a good sign that I'm doing things right. All right, the next thing that I need you to remember from Math 3 or other classes is the quadratic formula. Depending on how cool your math teacher was, they might have made you memorize it. They might have made you sing it. There's a song kind of like The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So I don't know if that rings any bells or you just had to really suffer through my singing. But anyways, you need to know that formula. So let's go ahead and start solving this problem over here on the left. Before I solve it, I do see an issue right here. That issue is that it's not equal to 0. So before I do anything, I have to move that over. So really, this problem is going to be x squared plus 12x minus 28 equals 0. Okay, so make sure it is in the right format first. Now, this formula uses an a, b, and a c. A is the number in front of x squared. Now in this case, I don't see a number, so that number is 1. B is the number in front of x, so that is 12. And C is the constant, so that is negative 28. Go ahead and plug all of that into the formula. So negative b is negative 12 plus or minus square root of b squared minus 4 times a times c all over 2a. All right, so I plugged in all my numbers, and we are just going to kind of plug and chug from here. Simplify what you can. I don't care if you use a calculator. I do believe if I type all that in, it gives me 256. 2 times 1 is 2. And then I'm almost done. Let's see. Of course, we all know that the square root of 256 is 16 all over 2. All right, so now let's, oops, I forgot the minus. Let's talk about that. Remember that plus or minus thing. So that means I have to rewrite it twice. So the first answer, remember there's 2 answers because there has a squared, it's a quadratic, so always have 2 answers. Some might be imaginary though. So it's going to be negative 12 plus 16 over 2. That's going to give me one answer. And then negative 12 minus 16 all over 2, that's going to be my other answer. So this is going to end up being, let's see, 4 over 2, which is 2, and negative 28 over 2, which is negative 14. And therefore, we have solved that quadratic using the quadratic equation, or quadratic formula. All right. Next problem, simplifying radicals. Those square roots will get us, and we're definitely going to work with radicals this year. So let's start out by just reducing a radical. Some of you might be able to do this in your head. Some of you might know that 18 is really 9 times 2, and the square root of 9 is 3. So if you know what I'm talking about there, feel free to do that part in your head, but I'm not. I'm gonna do it old school. So this is where we say 18 is the same thing as 9 times 2. 9 is the same thing as 3 times 3, and we're making a factor tree. And then what we like to do is we write as when we can't go any further, like 3 does not break down, we can write it as this is the same thing as 3 times 3 times 3, x, 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 y, 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 y. So basically, 3 x's, 4 y's, a 3, and a 2. And your teacher might have done some analogy where like, hey, if you have a partner, you get to go on a date, you get to leave the house. So pretty much anything that I can group into 2 gets to go outside of the house. So a group of 3's come out, and x come out, and 2 groups of y's come out. And the thing that I have left is a single 2 and a single x. They are lonely, they did not have a partner, so they could not leave the radical. Just go ahead and simplify that. So I'm not going to write y times y, I'm going to write y squared right there, and leave that as a 2x. And we have simplified the radical. So the next problem has to do with what happens when I have square roots in the denominator. So this, 3 doesn't break down obviously, but what we need to do is what we call rationalize the denominator. And that means you can't leave a square root in the bottom. It's a pretty easy fix. You basically multiply the top and bottom by that square root that was giving you trouble. So go straight across the top. 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 ends up being 3. If you need to like math that out, that's the square root of 9, but it ends up being 3. So that will reduce to the square root of 3 over 3. All right, I'm going to do that one more time with just a slightly harder problem. I'm going to multiply that by the square root of 6 and that by the square root of 6. So now on the top, I have a 2 and I have a square root of 30, and on the bottom I have a 6. So now let's go ahead and make sure that 30 doesn't break down. Let me use, let's see, so 30 is, let's see, 3 and 10 is 5 and 2. So actually 30 doesn't break down. There's going to be nothing to reduce in that radical. But what can reduce is, see this 2 and this 6? That's going to be a third. So 1 square root of 30 over 3. Now you don't have to write that 1. I just did that so that you guys could really visualize that I'm reducing that fraction right there. All right, next on the docket is the special right triangles, 30, 60, 90s or 45, 45, 90s. Okay, this is a little bit of the notes here. So in a 30, 60, 90, there's a pattern to the sides. The short is x, the medium is x square roots of 3, and the long side is 2x. So make sure you remember that pattern, x square roots of 3, 2x. If you don't remember, this is a great time to pause the video and write this in your notes. Okay, in class, this is where I would typically pause and let you write it. The 45, 45, 90 also has a pattern, x square roots of 2. So make sure that either you have that really in your brain or it is paused and it is in your notes. So how does that help us with this problem over here? So this is a 30, 60, 90. And that we are trying to find the hypotenuse. So we're trying to find the side that says 2x. And what they do is they give me the medium side. So what I know is that the medium side is 12. So that's saying like, hey, 12 is equal to the x square roots of 3 sides. So let me go ahead and figure out what the value of x is. So 12 equals x square roots of 3. Now, if I want to know what x is, this is x times the square root of 3. So I'm going to divide each side by the square root of 3 so that that cancels. And x equals 12 over square root of 3. Now we're almost done. Remember on the last slide I said you can't leave a radical on the bottom? So I have to rationalize that. So it really ends up being x equals 12 square roots of 3 over 3, which reduces to 4 square roots of 3. So wait, we're not done yet. Remember what we actually said we were doing is we were solving for x. So if x is 4 square roots of 3 and the hypotenuse is 2 of those, doesn't that make the hypotenuse 8 square roots of 3? All right, so hopefully you remember those concepts, factoring, quadratic formula, rational, special right triangles, and we feel good about those. So now that you are done with this notes, go ahead and you may start working on today's assignment.